Okay, so turn to page 324, and we're going to start over here at the Discover down on page 324, and go ahead and kind of read what it says, and then do 2A, B, and C, and then come back. So I'll pause while you do that. Okay, so remember when you graph points, you always go back and forth first to find the elevator, then you go up and down. So if I go over 4, up 5, I plot a point, and go backwards 3 and up 5. And notice this is a horizontal line, so it's straight across. So to get the distance for the question down here, all you have to do is count. So it's, 1, 2, 3, 4, 5, 6, 7. So that distance is 7. And so if you look at the 2 points, 4, 5, and say -3, 5. If I make my little XY table here, and if I did slope, notice the change here is 0. The change here is -7. Or if I turned them around, if I put the -3, 5 first and the 4, 5 second, the change here is 0. And the change here is +7. So distance is absolute value, so it's always positive. So no matter how I do it, this distance is 7. And I don't need Pythagorean Theorem because it's not at a slant. It's straight across. All right, go ahead and try number 3 on the next page. Okay, so again, this time we get a vertical line, which again, if something's a distance straight across, you can just count. And so if I count, this is what, a distance of 8 up here and a distance of 3 here. So it's a distance of 11. Now again, if I do my little chart and look at my 2 ordered pairs, 6, -3, 6, 8, this is going up 11, and this is 0. This would have undefined slope. If we talk about slope, you can't ski on it. But the distance, it's not slanted, so I can just see that the distance of it is 11. Now, if I turn the points around, it'd be a -11, but again, it would be the absolute value because distances are never negative. So when things are straight across, right, like on a number line, say I want to go from here to here, I can just count the little tick marks and say 1, 2, 3, 4, and say that these are a distance of 4 apart. The problem is when things get to be slanty, because then, like these aren't worth 1, right? These are worth 1 across, like each little tick mark, but on the slant, they hit at weird places. And so if you look at the bottom of that page and go ahead and read that example, we'll go from there. So read the example at the bottom of this page. Okay, and again, notice there's this icon. So if you want to go into the multimedia on my math lab, you can watch a video that the publisher made. So notice this time it's slanted, so I just can't count. There aren't nice little tick marks there. If I do my XY chart, so I have what? Input, output, and input, output. This is going down by 4, and this is going up by 3. But again, on slope, that would matter, right? Rise over run, the slope would be -4/3. But as far as the distance go, it's just absolute value. You don't have negative distances. And if you do, it doesn't matter in Pythagorean Theorem because a negative times a negative is a positive anyway. So this distance on my y, change in y, is -4, so I'm just going to call it 4. And the change on x, because this is your change in y, and this is your change in x, is 3. And again, if you want to put the negative there, you can. It won't hurt. And so to figure out this distance, we need Pythagorean Theorem. So 3 times 3 is 9, 4 times 4 is 16. And some of you might remember that's a Pythagorean triple. Most of these are not going to end up nice. All right, so then you're going to square root to undo the area, because the area of this square is 9, area of this is 16, the area of this is 25. But I just want that side length. So you square root and you get 5. Now again, remember you really technically get 2 answers. 5 times 5 is 25, so is a -5 times -5. But with distances, we only do positive numbers. Now, say you love that negative number there. All right, well, fine. Pythagorean Theorem would be a squared and then b squared, and you need parentheses here because of the negative. So notice if you do that, you still get a positive 16 because a negative times a negative is a positive. So even if you use the negative from over here, it's not going to hurt as long as you square it and get a positive. So you can flip and look at the next page and then go down to where it says how it works. So read page 326, and we will talk about that next. Okay, now this is the distance formula, and if you really want to memorize it, you can, but you can just do Pythagorean theorem. If you like to do slope by y2 minus y1, I don't even know why I put that like that. Sorry, we need some subscripts here. Y2 minus y1 all over x2 minus x1. So this is your change in y, change in x. Notice that that's what that is. So this is just, the distance you get here, the distance you get here, and then you square them, which is kind of like if we make the chart and we get the change in y and the change in x, those are your distances and your distances. So that's how this formula is come about. It's just like, okay, well, subtract these and square them. So this is kind of like your distance squared, like a squared and b squared. And then the last thing you do in Pythagorean theorem is square root. So this is really Pythagorean theorem just in disguise. So if you're going to use this, though, you have to memorize it. I will not give it to you. I always just do Pythagorean theorem, but that's up to you. All right, so go ahead and try number 4 on page 327. Do 4 and 5 both, and then we'll pick back up. Okay, so I want to find the distance between, 210, so say that's up here, and negative 5, 4, so say that's about right there. Okay, so I want to know that distance. So you could just kind of make a sketch, and you could draw the triangle in and figure it out. You need to know this distance on the x. Well, it's at a negative 5 and a positive 2, so this is negative 5, this is 2, so this has to be a distance of 7. And from 4 to 10 is a distance of 6. Now notice if I make my little xy chart to kind of help me, if I was, say, doing slope instead, what is it, negative 5, 4? This is going, what, down by 6, and this is going, what, down by 7. So I could take my rise over my run or my change. But notice a negative divided by negative is positive. But even if we're doing distances, we don't care about negatives. So slope we do, because obviously this has a positive slope. But with Pythagorean theorem, you just ignore the negatives, right? And so I'm just going to do Pythagorean theorem. So 6 squared plus 7 squared equals c squared. What is that? 36 plus 49 equals c squared. And then add those together. What is that? Steal one from that. That'd be what, 50? Is that 85? Equals c squared. And then again, this is all about area. So you have an area of 36. You have an area of 49. You have an area of 85. But you just want the side length. You don't want the area. So that's why the last step in Pythagorean theorem is always to square root. And so we're going to round, I don't know. Does it tell us? No. So about 9.22, and units, don't necessarily know what those units are. Okay, could be centimeters, could be whatever. All right, if you look at the next one, it says find the length of a diagonal of a rectangle who has a length of 10 inches and a width of 5 inches. So again, a diagonal is just the hypotenuse again. So that's Pythagorean theorem. Obviously, if it's 10 up here, it must be 10 down here as well. So I have 10 and 5. So again, Pythagorean theorem, you have 5 squared plus 10 squared equals c squared. 25 plus 100, because it's all about area. So the areas would add up to 125. But again, I want the side length. I don't want the areas. So use square root. And I got about 11.18 units on that one. So the distance between these 2 points is really the hypotenuse. That's Pythagorean theorem. All right, let's go to the bottom of page 327, and we'll try to connect some dots here. Okay, so here it says, write the expression, the distance for the slope using a and b. All right, so if you think of the definition of slope as rise over run, this is rising a and running b. So the rise is a and the run is b. So that would be your slope. Now, if you think of the distance formula, what's the distance? Well, again, let's think it's just Pythagorean theorem, right? So we have a squared plus b squared. We would do that first, and that would equal, in this case, they call it d squared. And then the last step is always to square root. So notice we would square root whatever we had when we did Pythagorean theorem, and that would be that. Okay, so in B, it says write the equations or expressions of distance using the coordinate system. All right, so this is using the formula y2. I don't know why I keep wanting. I've not been very good on my subscripts. Y2 minus y1 all over x2 minus x1. So that's the definition of slope we're using here. We're trying to use the ordered pairs. Okay, so then we're just going to sub in. So up here, notice A is the same as this. So y2 minus y1. Oh, shoot. I don't know why I can't do subscripts today. I am having a heck of a time. Let's try again. Y subscript 2 minus y1, and then squared, because A squared, plus, and then our B is this guy. Okay. Now, if you're like, but in the book they have it the other way around, well, remember we have the commutative property, so they just put the x1s first. So they just moved this and moved them around. That's commutative. So just probably so it's alphabetical and a little prettier, but it really doesn't matter. So they're just taking the distance on the y squared, distance on the x squared. And notice with this formula, you might get negative numbers in here, but when you square it, it's not going to matter. It's going to be positive anyway. So again, I just do Pythagorean theorem, but if you love formulas, there you go. All right, try number 7 on the next page. Okay, so when you graph, you always go back and forth first and find the elevator. So I went back 5, up 3, found the elevator, went up and down, went over to 7, found the elevator, went up and down. So those are my points. Okay, now it wants me to find the slope and the distance. So I can do this a couple ways. If you love the formula, I could do that. So y2 minus y1 over x2 minus x1. So negative 1 minus 3. And 7 minus a negative 5. Again, I'm going to add the opposite here, but again, you can use a calculator to add the opposite. Add the opposite. So what is that? Negative 4 over, what is that, 12? Looks like I could scale these both down. So divide both by 4. So what is that? A negative 1/3. And does that seem reasonable? Well, it's going down, so that seems reasonable. I could count. If I rise 1 and go backwards 3, am I on a point? Rise 1, go backwards 3, am I on a point? Yep, so that seems reasonable. The other way I could get my slope is make my little XY chart and kind of do the change, more of the rate idea. So this is going down by 4, and this is going up by 12. So change in y over change in x. So negative 4/12. Again, I can simplify to negative 1/3. So that's your slope. Now, what about distance? Well, there's a triangle in here, and I can draw it above or below. So I could draw it down here or there. Now, you can't use the reduced one because then you're using this little baby triangle in here, and you don't want that triangle. You want the original big triangle. So you have to use your original answers before you reduce. So negative 4 and 12. And again, so this is 12. And again, negative distances don't really make sense. So if you put a negative distance and you square it, that's fine. But for our sake, you can just leave off the negative. If you're in a trig class, actually negatives do matter, though. You can have negative distances in trigonometry, which is kind of weird, but that's the way it works. So again, you can memorize the formula here. Where's my, yeah, I want it all the way over here, don't I? So I want the original big triangle right there. So I could do Pythagorean theorem. So 16, 4 times 4, 12 times 12 is 144. I could add those together, and that looks like, what, 160. And again, that's area, so I'm going to square root, and I get about 12.6 units. And again, technically, I get two answers, like 12.6 and negative 12.6, but when we're dealing with distances, in real life, distances are positive. So the main idea here is you can use slope to help you, but not the reduced form. You have to go back to the original distances that you used to help you get slope to help you out. All right, I'm going to pause. Why don't you look at the homework number 1, 2, 4, and 5 for this section. Okay, so to check your answers, number 1 should be 12.0 units. Number 2 should be 6.4. Number 4 should be 10, either way you do it. And number 5 should be the length is about 12.04 and the slope is 9/8. So number 5 is length is 12.04 and the slope is 9/8. And number 4, they both have a distance of 10 either way you do it, which is the whole point. 2 is 6.4 miles and 1 is 12.0 units. So when you do those, just make sure you're getting the right answers on those 4.